Hi, my name is Paula Kirya. I am a bioengineering student at the University of California, San Diego. I decided to study bioengineering because I was interested in the intersection of biology and engineering, like the crossover between the two. But I specifically gravitated towards optics and photonics because of the potential to advance medicine in unforeseen ways, because light allows us to probe biological matter, probe disease tissues in a non-invasive manner. Current techniques involve using these chemical stains, fluorescent or pigment-based, that bind to these different molecules. So you're like intruding onto the tissue. It's very like a time-consuming process, a lot of steps. But when we manipulate how light interacts with matter, more specifically these very, very tiny materials in our bodies that affect the progression of disease and our functions, we can extract the same information without taking these extra steps and protocols and relying on all these chemicals. What excites me about this is the potential to scale down pretty complicated advanced technologies to very small scales when we're operating with like the visible light spectrum. That like makes things more portable, possibly more accessible, and maybe even more affordable because you're able to work with much smaller tools rather than these like bulky setups. So people from more under-resourced countries or communities have access to the same quality of diagnostics. I'm also excited by the prospect of furthering the advancements of like how we understand tissues and biological properties, because basically the smaller we go, the smaller we can probe different structures, like maybe even the molecular and atomic scale, which we can't really do with our visible eye. With our visible eye, we can do a lot of hands-on things. We can conduct surgeries, but at the end of the day, we do need to rely on the science to understand what's going on within a patient.